Yeah, for sure. And so we know that when there's leaky gut or intestinal hyperpermeability, like you talked about, it drives up inflammation in the body. And this kind of leaky gut, leaky heart connection, you're saying the endothelial lining or the very inner lining, because there's different layers of the heart, very inner lining is kind of held together again, similar to the gut, right? It's kind of held together by, little, I don't know if it's tight junctions. You may know the actual architecture there a little better, but it's held together and they can be that endothelial lining can become more permeable as well. Is that what you're saying here?
Yeah, no, for sure. And there is a lot of similarity, certainly again in the intestines and in the lungs, those are epithelial cells. So those are almost like skin type cells. And the inner lining of the blood vessels is called the endothelium, but there's so much similarity and similarity, for example, in the zonulin protein. So zonulin is a protein that allows those tight junctions to open up appropriately. But when we have too much zonulin, now we've got that hyperpermeability where again the gut leaks, the heart leaks, and now you open up those endothelial junctions as well, those tight junctions that you mentioned, and that just allows for proteins to get into the areas where we don't want them. We don't want the inflammatory cells to easily get into that space. And that, again, is measurable. We can measure zonulin levels. It's something that you do. It's something that I do. It's something that a lot of holistic practitioners do. Again, the medical doctors are just not addressing the connection between the gut and the heart. And certainly we could talk about leaky brain, we could talk about leaky liver, we can talk about leaky genitalia, we can talk about leaky anything where again that protective barrier is malfunctioning. And then of course what doctors like you and I do is to go after, well, why does somebody have that leaky gut or intestinal permeability and therefore suffer all the illnesses associated with it?
Yeah, absolutely. And so when proteins and inflammatory proteins and obviously lipids slip in through that endothelial lining and kind of get into the actual vascular tissue itself, it can drive inflammation in that area and damage the tissue. And then scar tissue starts to come in to help kind of protect it. Right. And then that is early phase of the pathogenesis of arteriosclerosis, atherosclerosis. Is this how it works?
Yeah, no, that's exactly how it works. And unfortunately, again, our brethren in the medical community just don't understand it. Like they continue to think that it's an LDL problem. They think it's a quote unquote a bad cholesterol issue, and it's not. Again, the human body just doesn't make mistakes. And we have LDL, commonly called the bad cholesterol. We have LDL, and that serves a purpose, right? It's made in the liver and it transports things around the body, again, fat soluble vitamins, ADEK, and energy molecules like triglycerides, and transfers CoQ10, has a tremendous antioxidant capability. So LDL has a purpose, HDL has a purpose. But the problem is that when the LDL circulates around too long for a variety of reasons, mostly having to do with hepatic dysfunction. And again, the inability of the liver to clear these old LDL particles. Well, now the LDL particles, they become older, and in doing so, they're smaller. They become damaged in a process of oxidation and oxidative stress, which is easily measurable and clearly linked to cardiovascular events, heart attack, stroke, dying. And it's the oxidized LDL that is easily taken up into the coronary arteries. And then from there, right, it's swallowed up by the immune system. These monocytes become macrophages. Macrophages become foam cells. And then to where you were alluding to, those foam cells die. And in the death and destruction process, they become calcified areas, and then that leads to instability of the coronary plaque, and then ultimately to rupture. So, that's really where it all starts. And I think in a lot of ways it goes back to that healthy liver. Healthy liver, of course, ties in with the healthy gut. And if we can just make sure that we give the gut what it needs, take away the poisons that it doesn't need, well, that's going to be the answer. The answer is not in the pharmaceutical space. For anyone who's listening, again, they're thinking about, well, again, statins were recommended or blood pressure drugs were recommended. Those are a very lame attempt at a Band-Aid approach, and they just don't work. They just, again, blood pressure drugs can lower blood pressure. Statin drugs can lower cholesterol. But as far as meaningful changes to decreasing your risk of heart attack, stroke, and dying, at best, it is a small benefit. And at their worst, according to some literature, they actually increase cardiac events and actually increase your chances of dying, according to some studies. So please understand that there is definitely a much better approach than what standard doctors are offering.
Yeah, that's super important to understand, because statins will damage the mitochondria within the cell that produces all the energy. And if we're going to have a healthy gut, if we're going to have a healthy vascular system, if we're going to have a healthy liver, we need healthy mitochondria.
Yeah, it's so much, it's kind of like you and I talk about, Hippocrates said this, and it's kind of like what's the first thing to break, or what's the most important thing? And I think ultimately a lot of people certainly now talk about it's the mitochondria, right? And disease all starts in the mitochondria, the fuel factories of the cells that produce cellular energy, but produce cellular water and maintain the electromagnetic fields, and also lead to start the process of mitophagy and autophagy. And I know you've written extensively about all these things as well. But yeah, statin drugs, they're mitochondrial poison. That's what they do, is they inhibit the enzyme called HMG-CoA reductase. And whenever you inhibit something that's naturally occurring in the body, you're going to have consequences. Now, one thing that the medical system would say is a positive is that you decrease the production of cholesterol. Because again, it's how you make cholesterol is through a multi-step process that essentially turns food or fuel into cholesterol. Now, you and I would both say, well, cholesterol again is very important. All animal species have cholesterol. The chicken egg contains cholesterol for a reason. Human breast milk and all milk contains cholesterol for a reason. And our bodies need cholesterol to make vitamin D and the hormones and the digestive processes. And in fact, the cellular membrane, or the two brains of the cell, is loaded with cholesterol. And in fact, the mitochondria has a pretty fair amount of cholesterol inside of that as well, including the other organelles, or the tiny structures inside all cells. So again, cholesterol is very important. So if you're not making cholesterol, bad things are going to happen. Cell membrane, mitochondrial function, you name it. To your point, again, you don't make CoQ10, which is part of the electron transport chain to make ATP in cellular water. You also limit the production of something called heme A, and heme A is a protein that is found inside of cytochrome C oxidase, or the fourth molecule in the electron transport chain. And if you're not making heme A, well, you're going to have dysfunctional cytochrome C oxidase, and therefore limit your production of ATP, cellular energy, cellular water, and you're going to just suffer from this energy drain. And if you have deficient cellular energy, anybody can imagine that, it's going to lead to horrific consequences. So the other thing, David, that I talk about is that another thing that is inhibited by statin drugs is dolichol. And dolichol is a steroid-like molecule that is in it's the highest concentration is actually in the substantia nigra of the midbrain. Now, the substantia nigra is a very important structure of the other brain, as all brain structures are very important, and that really has to do with movement, and ultimately disorders of the substantia nigra lead to movement disorders such as Parkinson's and the like. That would be the most famous one, and there's many others, but Parkinson's obviously is afflicting millions and millions of people, and it could be benign essential tremor, all these things that are in the substantia nigra. Well, dolichol is located in the cells of the substantia nigra. So the literature tells us that statin drugs actually inhibit dolichol production. Biochemistry, we can see it, but we can actually see it functionally, where again it's limited, and ultimately that's why there's plenty of data that links statin drugs to movement disorders such as Parkinson's. So no free lunch with statin drugs. I have not written a prescription for statin drugs in about 9 years, and there really is no place for that, I believe, in medicine.